Right, in the next problem, we're looking at the integral of x to the power 7 divided by 1 plus x to the power 16 dx. Off the bat, it's not immediately clear that this is an arctangent problem because for arctangent, we're typically looking for a denominator in the form of 1 plus x squared. But this is what we call an arctangent wannabe kind of a problem. So if we rewrite this expression as the integral of x to the power 7 divided by 1 plus x to the power 8 quantity squared, we do see that 1 plus a quantity squared forming in the denominator, which is going to allow us to use that arctangent formula. So for this problem, I would like to let u be equal to x to the power 8. And so resulting from this, if we find the differential of u, du is equal to 8x to the power 7 dx. Now note in your problem we do have x to the power 7 dx, but this 8, this coefficient 8 is slightly in my way. So let's move it to the other side. So we get 1 over 8 du is equal to x to the power 7 dx. So this is going to make for a very nice substitution. I get the integral of 1 over 1 plus u squared times 1 over 8 du. If we clean this up ever so slightly, in other words, just factor out that coefficient 1 over 8, we get 1 over 8 times the integral of 1 over 1 plus u squared du. All right, so we can go ahead and integrate. We know that this is the arctangent form, so this is 1 over 8 arctangent of u. We want to go ahead and next we're going to back substitute. Remember, u is equal to x to the power 8, and so that yields 1 over 8 arctangent of x to the power 8 plus c. All right, my next integral here, I have the integral going from pi thirds to 2 pi thirds of cosecant squared evaluated at 1/2 t dt. So for now, let's disregard the bounds. We're going to treat this as an indefinite integral, and then we'll come back at the end and put the bounds back on. So the first thing that I'm going to go ahead and do is I'm going to go ahead and declare that my u here is going to be 1/2 t. So I don't like the composite function here, so I will replace the 1/2 t, 1/2 t by u. All right, so this immediately means that du, my differential, is equal to just 1/2 t. I'm sorry, 1/2 dt, of course. And so I do have a dt in my problem, but not a 1/2. So I'm going to multiply both sides of this equation by 2. Now I'm ready for my substitution. All right, so if we substitute, we will get the integral of cosecant squared of u times 2 du. All right, so again, coefficients are really easy to work with. We're just going to factor them out. So this means we have 2 times the integral of cosecant squared of u du. Of course, the integral of cosecant squared of u is equal to negative cotangent of u. Keep in mind, we still have the coefficient 2 on the outside. So this cleans up and becomes negative 2 cotangent of u. I'm going to choose to back substitute. Now you could either back substitute or you could convert your bounds. I'm going to go with the first technique, so I will back substitute. U is equal to 1/2 t. So that gives me negative 2 cotangent of 1/2 t. All right, so next we want to evaluate. Keep in mind this was in fact a definite integral. So I would like to evaluate. The integral from pi thirds to 2 pi thirds will be equal to negative 2 times cotangent of 1/2 x, evaluated on those bounds. I'm going to just follow the fundamental theorem of calculus here, and I will plug in top minus plug in bottom. Note that I left the coefficient negative 2 outside of this calculation. That's an easy way of not having to kind of carry around too many coefficients, especially negative coefficients. We can put it back at the end. But now we have to evaluate. So if I just clean up, I'm going to get negative 2 times cotangent of pi thirds minus cotangent of pi over 6. So if we would like an exact answer for this integral, we will need to consult our unit circle. And so when I look at the unit circle, I see that cotangent evaluated at pi thirds is equal to the square root of 3 over 3. And cotangent evaluated at pi over 6 is equal to just the square root of 3. We can now go ahead and just distribute that coefficient -2 back in and clean up the inside that we have here. So I actually get my exact value here would be 4 times the square root of 3 over 3. If you wish to give a rounded value here, the rounded value that I would get here would be 2.309.